form. What is the level form? Using raw data. Using the raw data, which consists of long-run information. When you are differencing the data and you are estimating VAR, and which will give you the short-run information. Short-run information. Okay, so the VAR is applied for both long-run and short-run. Okay, so moreover, the short form of the VAR is the Granger causality test, where it will provide you the Wald F test. So based on the Wald F test, so we are going to infer about whether X causes Y or Y causes X, or what is the third possibility? What is the third possibility? One is X causes Y and Y causes X, then it's a bidirectional, and the last one independent. Okay, so that is what we are going to test using the VAR and GC. So on one more thing, don't only stick to the causation. In fact, how the shock created in one variable has an impact on the shock in the other variable. In a system, you say system consists of two variables, X and Y. When you are giving a shock to one variable, and how the other variable is reacting it. So which we call it as impulse response function. We call it as IRF. That we'll see later. First, we'll see the just causation. I'm going to explain the VAR in terms of the cause and effect relationship between two variables. So when it become a long run, when you are estimating the equation with the level, it produces the long-term information. When you are estimating the equation using the first difference, will provide you the short-term information. Okay, so with this, we'll share one database. We'll share you the database, which consists of two series. So one is the spot price, the other one is futures price. Anything you can take, as I told you, like FDI and export and import you can take, or the trade, or you take FDI and GDP. I have taken the spot price and future price, the two series. Any two series you can take at your area of research. So what I'm going to do, I'm going to use two variable to estimate VAR model. So what is the first step to start with? What is the procedure? Econometric procedure. The first step. Very good. So we are going to test the stationarity. Then we will decide which model to be, whether you're going for the co-integration, or then VCM, vector error correction, or we'll go with the Granger causality or VAR model. Okay, fine. So now you'll get the database. What you can do is, we are going to first we are going to check the stationarity property of the data set. Then followed by, we are going for VAR model. Okay, VAR model and the Granger causality. We'll see, we'll decide on it. What it says, that whether it is a mix of integration or it's going, I mean, mix of integration, right? One is in I of 0, the other one is I of 1, or we'll go for whether the stationarity at levels, we'll see to it. Okay, fine. So once you get the data, just download and keep it. The name of the file is VAR, VAR. Okay, so name of the file is VAR. We'll estimate and see. Okay, fine. So first thing you said, we are going to conduct ADF test. For how many? For two variables. And give me your suggestion that whether it is I of 0 or I of 1. Very good. That's it. Okay, fine. The same thing, one more thing, just to add into it. The specification of GC. Listen, one question. Small question. Let me see. Which coefficient is important? I told you in the morning, right? Which coefficient is important? Here it is beta 1, right? Here it is beta 3. Here it is beta 3. Correct? No. Now, do you remember each coefficient, how to test whether it is statistically significant? How to check, how to check whether it is statistically significant? Each coefficient, I told you. Whether sign is, first one is sign, right? Plus or minus. Followed by, size, magnitude. Very good. Then, is it statistically significant or not? So which test you will apply? Which test will be there? Very good. What test? T-test. So what is the purpose of T-test? To examine. T-test is used to test the significance of individual coefficient. Individual coefficient. Student, listen please. T-test is used to test the significance of individual coefficient. Sir, we studied T-test is used to compare the sample mean and the actual mean. That is different. Okay, don't bring it here. That is one sample T-test. No, so what do you find one sample? That is no based on the scenario, right? Different scenario. So T-test used to compare the difference between the sample mean and population mean. So mu and X bar, that's a different story. So here, this context, the T-test is used to test the significance of individual coefficient. Very simple. One more test I'm going to introduce now. One more test. So here, listen. Technically speaking, what is the null? What is the null for beta 1? What is the null of beta 1? No. This is VAR setup. This is VAR model. Very good. She said there is no impact of XTs. XTs means what? It can be -1, -2, minus XTs on YT. There is no. Very good. Beautiful. What is alternate? There is. So how to write technically? H naught. What is H naught? Null of beta 1 is equal to 0. There is no impact of lag values of XTs on YT. So how to technically write? This is very important. Beta 1 is equal to 0. What is alternate? Very good. So H1 is beta 1 is not equal to 0. Very important. Each and technically, I'm writing very technically. Madam said no, like in terms of statement, sir, there is no impact. Obviously. How to write technically? You have to specify no equation. So technically, H naught is nothing but the beta 1 is equal to 0 and H1 is beta is not equal to 0. So how to test it? Audience, how to test it? I know you know the answer. Students, how to test this? I told you yesterday's session you attended, no? Tell me how to test it. How to test it? Come on, yeah, this hypothesis testing, you know, how we are to test? You are going to take a call, whether to accept null or reject null, how to take a call? Using? Sir, whether to accept null or reject null, no, how to take a call? Using? I raise the question, no, is it statistically significant? T-test, come on, T-test. I told no, T-test. T-test. And also there's one more value, no, associated with the T-test. What is that? Rule of thumb. Probability value. Have you seen regression? No, regression. Each and every coefficient is attached to, pertain to T value and probability value. Morning, you only said, no, in all AR model, you only said based on T and probability value. Why hesitate? Same here. After estimation, so how many T value you will get? How many T value? For alpha, how many coefficients are here? Alpha 1, alpha 1, beta 1, beta 3. So how many coefficients? 3 coefficients. How many T value? 3 T value. How many probability value? 3 probability value. So here, B1. But we are worried now, we just look at the B1. I don't want this. Now, here which coefficient? Beta 3. So T value of beta 3 I want to see. To examine whether the lag value, the YTs has impact on XT. Okay, because they are AR form of the model. Var. Okay. Okay. So now I'll get t value, audience, I'll get t value and also p value of beta 1. Okay. So what is null? You know that you only said the null is there is no impact of xt on yt. Xt is on yt. So we are giving priority for not only the xt minus 1, previous value. So lag model, no, xt's, previous values of xt's. Okay. So yt is a function of xt minus 1 and it will go on. The lag length will go on. We do not know. How many lag length here? What is the lag length here? How many lag? Think and tell me. How many lag I have taken? T minus 1, 1 lag. T minus 1, 1 lag. So this is optimal lag length is 1. Optimal lag length is 1. So how to decide lag length? That's the question. It might be 3, it might be 4, or it might be 5. Why? Because you know that I told you, I explained that yt is not only influenced by xt minus 1, it is also influenced by the xt minus 2. Who knows it? We do not know. So we have to fix it, optimal lag length. How long it will go, we do not know. How many lag it will go, we do not know. So we have to fix it. Optimum lag length should be. Okay, so how to fix it? We'll see. The lag length plays very important role in the causality test. Lag length plays very important role, key role in causality test. War is a causality. Vector error correction model is a causality. ARDL framework is a causality. Morning I told no all this. Okay. Impact also you can see. You can also study along with the causality. Okay? Understand? No? So this is the way how to check the statistical significance of each coefficient here t value. Now we'll go for there is something called F test. F test. Students, please. F test, very basic. F test. What is F test? F test. F test. Have you noted down T test? No? The TSA count, time series analysis. Right? Now, same F test with respect to the time series. A F test used to test the joint significance of the coefficient. Joint significance of the coefficients, plural. T test for how many coefficient? T test for how many coefficient? T test know how many? If you check the chat box, I know I'll get the answer. I have read all the chat information. They beautifully reply to our ARIMA. The online session, I have tested it. They posted all the, the chat box, with the reply. I was very happy that. Which model is best model? They have tried it. I am very happy. So now T test the significance of how many coefficient? One coefficient. So that is what, how many t value you will get it in the equation? 1, 2, 3. Here also 1, 2, 3. What is the F test? F test is the overall or the joint significance of the model. Now that's joint significance what? The coefficients in the model. So how to write? How many coefficients are here? H naught. Okay. Now joint significance here. What is joint significance? Let's say beta 1 is equal to beta 2 is equal to beta, there is no beta 3, 0. Understand? No? What is the alternate? Beta 1 is equal to beta 2 is not equal to 0. Got it? Now, let me apply this hypothesis in this framework. Let me apply this hypothesis testing in this framework. This framework. Assuming how many lag length? Assuming how many lag length? Lag length is 2. Here, how many lag length? Lag length is 1. We'll go for lag length 2. Lag length 2. How to rewrite this model? Can anyone write and show me how to rewrite this model? Plus beta 3. Lag length is how much? 2. xt minus 2 plus same model I'm extending beta 4 delta xt minus 3 plus beta 5 xt minus 1 beta 5 delta xt xt minus 1 plus beta 5 yt minus 2 plus ut. See, listen, what I have done it. Yt is equal to alpha 1 plus beta 1 delta xt minus 1 plus beta 3 delta xt minus 2 plus beta 4 delta yt minus 1 plus beta 5 yt minus 2. Listen, when I say optimal lag length, it should be applicable for whole model, not for individual variable. I'm clarifying your doubt. The lag length, this is a bivariate setup. Lag length varies. The lag length varies. For entire model, there is a model called ARDL model, where the lag length varies to subject to variable. That is the advantage of it. But here, the optimal lag length is applicable for entire VAR setup. Okay, fine. Now, can you rewrite this model? Anyone? Can you write the second equation? How to write the second equation? You tell me, I'll write. Let me start with the B6. Okay. Beta 6 delta yt minus 1 plus beta 7. Beta 7. Very good. Yt minus 2 plus beta 8 delta xt minus 1 plus delta xt minus 2 plus this is u1t, this is u2t. That's it. Please. Beta 1 delta xt minus 1, beta 3 delta xt minus 2 plus beta 4 delta yt minus 1 plus beta 5 delta yt minus 2 plus u1t. Can anyone tell me what are the coefficients are very important in the first model, first equation? How many coefficients are very important? So beta 1 and this should be beta 2. Yeah, beta 2 and this should be 3 and this should be 4 and this should be 5 and 6, 7. Beta 8 delta. Tell me what are the coefficients are important here? Which lag coefficient are very important? B1, beta 1. Then beta 1 and beta 2. Because the lag length is 2. The second equation, beta 5 and beta 6. Correct? No. Correct? No. So either you can see the t value of these two, or t value of the first two, or you can go for F test. F test. How many coefficients here? More than one coefficient in each equation. So how to go about it? Beta 1 is equal to beta 2 is equal to 0. Beta 1 is equal to beta 2 is equal to 0. What is the alternate? What is the alternate? Beta 1 is equal to beta 2 is not equal to 0. Here we can't apply t test, F test. Why F test? Why F test? Here why F test? Very good. More than one coefficient, I go for the F test. Sir, it is only one lag length. Only how many lag length? Only one lag length. So directly you can refer beta 1 and directly you can refer beta 2. Sorry, beta 1, or might be next equation coefficient you can refer. You got some idea? See, while estimation, if I'm not explained this, when I go for estimation, you get a lot of doubt. You'll get a lot of doubt, I'm telling you. 100%. So with this explanation, why t test, why F test? Because the Granger causality is supported by Wald F test. War model is supported by the t test. Individually, we can look at it. Then question comes, sir, which lag we need to refer? The optimal is 4, optimal is 3, optimal is 2. So can I go for estimation? Can I go for estimation, madam? Sir, go for the estimation. Hope you got the data. War. The name of the war. Okay. Just keep two variable I have created. Two variable I have created. Two variable I have created. Okay. So I'll go for the estimation. Audience, just please follow. It's a practical. Okay. So I'm going to do war. First, what you have to do, you go for testing ADF. How many variables are there? How many variables? How many variables you have in the file? Two variable. Two variable. What is the name of the first variable? CT1, CT2. First column. CT1, CT1. What is the name of the first variable? First column, CT1. ஆமா அப்படியே இது போயிட்டு இருக்குல்ல CT1 CT2 சரி இது ஒரு மெயில் அனுப்பேன் வேற காண்ட்ரா அமைதியா CT1 CT2 மாடல் நான் போட்டிருக்க மாதிரி இருக்கா மற்ற CT1 CT2 இதெல்லாம் எப்படி போட்டேன் ஷேர் பண்ணி வச்சுல சார் அதெல்லாம் ரேண்டமா தான் போட்டுறேன் இல்ல போட்டேன் got the data no இது ஒரு யூனிட் டெஸ்ட் இது செகண்ட் யூனிட் டெஸ்ட் இது மாடல் எக்ஸாம் ஓ இது தனி எக்ஸாம் இது ரெண்டு ஆப்ல போட்டாங்க CT1 CT2 தனி மாடல் தனி எக்ஸாம் தனி மாடல் எக்ஸாம் மொத்தமா சேர்த்து அசைன்மென்ட் நான் கொடுத்தேன் அதே மட்டும் நீ 10 மார்க் கொடுத்தீங்க இந்த கேமரால கை போடு நான் போறேன் நீ தான போற okay that's okay by default no all the files will be open in EViews that problem she has open with EViews கொடுக்கலாம் correct தான் that is also fine first the mark எடுத்து சொன்னா 35 plus 47 and the excel okay can you please start with the ADF and tell me what is the order of integration then I'll tell you whether the var which are going to apply it is giving a long range information or short range information 17 10 வந்தனா 44 போட்டுருக்காங்க you start with yes or they no அண்ணா இதுதான் கரெக்ட் one more thing there are four variables no four column right அது எல்லாமே ஒரு மார்க் கம்மியா இருக்கு நெக்ஸ்ட் சொல்றேன் பாரு yes ஒரு மார்க் அதிகமா இருக்கு ஏன் அப்படி போட்டுருக்காங்க தெரியல 38 f plus 30 what is the third one 54 plus 8 6 yes very good 11 ls 10. We want ls lf We are going to deal with the
32
log
வருதா?
value.
31 தான் வருது. 34 போடுது.
Please mute yourself.
First one on the
Please mute your mic.
இது புரியுது. இது எப்படி பண்றீங்கன்னா
LS, log of
பண்ணுவாங்க.
spot
100
and log
மார்க்
of
25
inches.
தான் கன்வெர்ட் பண்ணுவாங்க.
Someone's
இந்த மாதிரி
mic
நீங்க
is
Do the
on.
analysis.
Kindly
Do the
mute yourself.
stationarity test for both.
என்ன பண்றீங்க? ஆனா
Please tell me whether the LS
அப்ப என்ன பண்ணுவோம்?
is stationarity at level or first difference.
இது ஓகே தானே?
Level or
ஓகே தான்.
first
நம்ம
difference.
கேட்டு
Come on.
சரி. நீங்க கிட்ட பேசக்கூடாதுன்னு நினைச்சேன்.
Hello. Someone's mic
LS,
is
LS or
on.
L.
Kindly mute yourself.
They are integrated in order 0 or 1.
ഇവർക്ക് രണ്ടുപേർക്കും അറിയാം, കൃഷ്ണയ്ക്കും അറിയാം. എനിക്കറിയാലോ, ഞാൻ പഠിച്ചു പറഞ്ഞു. ഞാൻ എനിക്ക് തരാൻ പഠിച്ചു പറഞ്ഞു.
Go to the series statistic.
ക്ലാസ്സിന്റെ ലാംഗ്വേജ് ആദ്യമല്ലേ മലയാളം ഉണ്ടായിരുന്നു.
Select the option. By default, option will be there. By default, no, all the options will be set. Just click OK. No, deal with LS, madam. Deal with LS. I don't want to know for S or F, LS and LF. Because I converted into log then the file. You done, madam? What is the interpretation for LS? LS. No. I'm asking, is it stationary at level? Okay, this is not stationarity at level. Okay. Then what you did? You went to first difference, correct? Then it become stationarity. Very good. So this is I have one. What for LF? What for LF? Do it. Now you learn, no, you do it. So LF. Okay, first difference. So I of 1. I of what I supposed to do? Both morning I told you, what is the procedure you have to start? When both variables are stationarity at the first difference, then you have to go for the co-integration. From the co-integration, you have to go for the VEC model, the vector error correction model, right? Anyway, so what we are going to see, we are going to do how to do it. I'm going to explain how to do it, show you the demo, how to do VAR model. Now, it's very clear. It's very clear. This data consists of the long run as well as short run information. Understand? No, that's what morning I told you. Co-integration for the long run. The short run, I'm going for the vector error correction model. Clearly, I explain step by step. Three flow chart. Three. Now, what I'm going to do, I'm going to directly go for VAR with the first difference data. First difference data. Why? Because both are stationarity at first difference. So I'm going to estimate VAR with the first difference data. Then we will see what is the result. Okay. So I'm going to share the screen and estimate VAR mode. Okay, you can see the data. Please see the data. The first two are actual data of spot price and the futures price of the agriculture commodity index. Okay. So anyway, you just keep it as a variable S and F. And the next third column, you can see this is a variable of LS, the log of spot price, and the log of futures price. Okay. So now I'm going to do the VAR model, the first difference form. How to do it? Just open the data in EViews file. Just drag and drop it on EViews. Will be opened. Okay, you got this page, right? So now go to quick. Go to quick. Estimate VAR. Estimate VAR. Estimate VAR. Go to quick. Estimate VAR. So before estimating VAR, I told you these causality models are subject to the selection of lag length. Selection of lag length. So type LS, LF. Type LS, LF. Click OK. Click OK. Don't do anything. Don't do anything. You got this result? Didn't get the result. LS space LF. You got this result? Don't read the data. Nothing. I don't want this. Just I am going to know. Just I am explaining the process of how to select optimum lag length. Okay. Go to view. With the output, select view. Have you seen here? Lag structure. Have you seen lag structure? Go to view lag structure. If you just click the lag structure, you will get lag length criteria, the last option. Lag length criteria, the last option. What is the last option? Lag length criteria. What is the default lag length? What is the default lag length? Automatically it is mentioned. No, how much? 8. You also get 8 only. Correct? No. You want me to repeat? I am repeating again. Go to wave. So lag structure. In the lag structure, you can see the lag length criteria. Click the lag length criteria. By default, it will be 8. Okay. Click OK. Now look at the lag length criteria. So how many lag length? LR, FPE, AIC, SC, HQ, Hanan, Queen information criteria. So how many lag length criteria? You can see 1, 2, 3, 4, 5 lag length criteria. 5 lag length criteria. Right. Sir, which one to be used? Which one is the best one? I don't want to enter into the debate. I don't want to enter into a debate. Sir, which is the best criteria? Optimal lag length criteria to go for. How many here? 1, 2, 3, 4, 5. LR, FPE, AIC, SC, HQ. Sir, which one to go for it? Look at the LR. Can you see the LR with the star? Can you see the star? LR, come on, yeah. LR column. Are you able to see the star? So what is the lag length? I'm asking which lag length. Forget about the statistic. 7. Lag length is 7. So LR suggests to go for lag length 7. Okay, FPE 7. AIC 7. Okay, HQ 2. No, HQ 2. And SIC? SIC 1. Now you take a call. Which one to be? Which lag length to be? Conduct. Sir, I will go with SC, SIC. Quasi information criteria. I want to go for it. Yes, go for lag 1. Sir, no, sir. I want to go for lag length 7 because according to LR and FPV, not only the AIC, the lag length is 7. I'll go for it because 3 criteria suggested 7. I'll go for 7. No problem. No issues. Go for it. No, sir, I go for quasi information criteria. Then go for it with lag length 1. Your choice. I don't want to involve into debate between. Sir, since 3 lag length suggested, 3 criteria suggested 7. One is LR, the other is FPE, the AIC. Yes, go for it. No, sir, I'll go with the SIC. Yes, go ahead. Sir, HQ. Yes, 2. Yes, go for it. In the article, go for the reference. In the article, go for the reference. While writing article, no, go for the reference. Which one is the best one? According so and so, AIC is the best one. Yes, go for the AIC best one. SIC is the best one. Go for it. Okay. So which one we can estimate now? Which lag length can we use? You tell me. If it is lag length 1, it is very easy. It is for me easy if we go for lag length 1. Lag length 7, the estimation will be huge. Specification very lengthy. So which one you want? I'll give option. 1 or 7 or go with 2. You want to go for 7? You tell me. 7 means the specification become till 7 lag length. Because there is a justification also, sir. There are 4 criteria. 1 star, 2, 3. 3 criteria suggest 7. So we go for 7. Yes, I will go for 7. No, sir. The SWOS information criteria 7. Yes, we go with 2. Sorry, the SWOS information criteria suggest 1. Go for 1. But the HQ suggested 2. Will go for it. Anyone, you select. Can you go for 1? First, we'll see the result. We go for 1, we see the result. Then we'll go for 2, we'll see the result. Then we'll go for 7, we'll see the result. What is the change? Okay. But one thing, you have to conduct war. The level or first difference? You have to conduct the war in the first difference or level. I'll raise you the question. I'll ask you a question. If you say, I'll give a chocolate. Tell me. I have to estimate war using first difference or level. Level, I can't use non-stationarity data. So I have to go for first difference. I should go for first difference. I should go for the first difference. So I'm just explaining you the procedure of going for, how to estimate war. But the actual procedure I'll tell you later. First you learn war. First you learn war, how to estimate. Then later I'll correct it whether right or wrong. Okay. Can you go for it now? Yeah, what you have to do? Go to quick. What are the lag length? What are the lag length? 1, 2, and 7. Okay, go to quick. Estimate equation. No. Go to quick, estimate var. Go to quick, estimate var. What are the variable? First difference data. So D of LS. Yes, you are right. D of LS space D of LF. First difference data. D of LF. Got it? Have you specified? D of LS. D, open the bracket, LS, close it, space, D of LF. First one is LS, second one is LF. D of the second one. D of, open the bracket, LF, close the bracket. What is the lag length? 1, 1. First one we'll see 1, 1. 1 for first equation, another one for second equation. So it is 1, 1. It is 1, 1. Can I go for estimation? Very simple. The box, just enter the variable name. Just go for 1, 1. Lag length 1 space 1. Done? No. Can I click OK? Okay. Just I'm click enter. Yes. Click OK. Delete var. Yes. This is the result. How many of you got this result? Very good. This side? No, this side. How many of you got the result? Very good. So nothing to worry, you'll get it. You're attending, no, you'll learn it. Because sometimes, when you are attending the lecture, knowingly, unknowingly, it will be stored here. I'm telling you 100% true. Whether you are interested, not interested, knowingly, unknowingly, the content will go here. You will realize the value when you are studying it. Yes, somewhere we studied this, yes. So whatever that sir said, it is correct. What do you feel, madam? Correct? No? Yes. Seriously. At least some points will enter. Okay. Now look at the result. Look at the result here. Your screen. Look at the first equation. Please look at the first equation. First equation in terms of column. You have to read the data column wise, not row wise. Column. It's a pivot table. Okay. Look at the equation. First one. What is the dependent variable? What is the dependent variable here? First equation. D of LS. D of LS is equal to. What is the first variable? Independent variable. What is the first one? Lagged value of Look, just show the camera. Actually, ds is the dependent variable. Look at the independent variable, ds minus 1. ds minus 1. There. ds minus 1. Then followed by df minus 1. Which coefficient is important? The first one. Which coefficient is important? Dependent variable is spot. And what is the important coefficient here? Here. In this column, which is important coefficient? You told no, here I specified no. YT. I least bother about the lagged values of its own term. I'm just auto-regressive term. I'm own lagged auto-regressive term. I'm least bother. YT is a function of lagged YTs. XTs. Now you come back to the result. This is the first equation. Dependent variable is d of ls. This depends on its lagged value followed by lagged value of future. புரியலையா? சொல்லணும். நாமான்னு ஓடிட்டா எனக்கு தான் பெனிஃபிட். வந்தோம் ஏதோ பார்த்தோம் போனோம் அப்படின்னு ஆயிடும். படிக்கணும். When I'm teaching statistics, I used to say to my students, 80% of the problem will be solved once you're able to read the data, understand the problem. 90% you'll get the solution. Whether you go for the normal distribution or Poisson distribution or binomial distribution, once you read the data, you could able to understand. Or whether you're going for the addition theorem, multiplication or complementary theorem to be applied, 90% of the problem will be solved when you read the data, when you read the question. You read the data. 10% is your solution, which already you memorize for the examination. P plus Q is equal to 1, 1 minus Q equal to P, or 1 minus Q is equal to P. Similarly, taking the output is easy. You first read the data. That's what I'm struggling here. So what is the dependent variable? D of ls is the first equation. Correct? No. எனக்கு இந்த இது இல்லை, பாயிண்ட் இருக்கு. மார்க்கர் அங்கே வைக்க முடியாது, காட்ட முடியாது, ஹைட் இல்லை. சார் எனக்கு கொஞ்சம் சார் நான் சொல்லிடுறேன். இல்லை சார், இது வேணும், ஸ்க்ரீன் ஷேரிங் கொடுக்கணுமா? Yeah. Look at here. Listen here. What is the dependent variable for the first equation? D of ls. Followed by, look at vertical. Followed by D of ls minus 1. D of lf minus 1 constant. So which coefficient is important here? This is important. Is it statistically significant? Is it statistically significant? Sir, how to see? Okay. So here, the t-test. Look at the t-value. T-value is provided in bracket, no? Square bracket. What I told you? What is the benchmark? 1.96. Is it greater than 1.96? Leave the sign. No. So it is statistically insignificant. So F does not leads to yes, over. Correct? No. F does not leads to simple. Now look at the second equation. Which coefficient is important? D of LF. Which is important? LS. Is it significant? So both are independent. What is the conclusion? Future bet does not impact on spot. So both are independent. But I don't want to believe the result of this. Why? Because how many lag length? The lag length is 1. I think I can go for 7. Best. Because 3 criteria suggested 7. Can you go for 7? Okay, I'll go for 7. I'll go for 7. So how to do it? How to do it? Just I share the, see, please go to estimate. Change it to 1 space 7. Change into 1 space 7. Click OK. Yeah, it's working. Very poor result again. Look at the dependent variable. Okay, look at the dependent variable and look at the lag 7 of DLF, lag 7 of lag value of the lag value of 7, D7, DLF 7. Yes. Significant? No. Same to look at the other side. That is also insignificant. How to look at? Here, here, here. Correct? No? So what to do? You are disappointed. Not disappointed. This is actual result. Actually. So you can substantiate that. Yes, you have to write the paper in such a way that both are independent. Both are independent. Here I consider 7 because lag length, the 7th coefficient, because the lag length is 7. Lag length is 7. But there is one more option is there. The third lag, no? There is 2 lag. Huh? 2 lag. I don't think so. 2 lag will work out. Second value. You try it and tell me. 1 space 2, right? That's it. Come on. You try it and tell me. Is there any reinforcing effect? Are they one way? Horrible, no? So what is the conclusion? So both the variables are independent. But I have one option. Why can't you see the joint effect? You know what a joint effect means? F, F, F. Joint test means F. So how to see? We'll go for the Granger. Go for the Granger. Okay, how to go for the Granger? Come back, no, sir. How many points? Close பண்ணிட்டோம். Firefox click பண்ணா போயிடலாம். இதுதான் வரணும். கனெக்ட் ஆகும். கனெக்ட் ஆகும். So have you tried, sir? No, only for Granger we are going, no, now. ஆன் பண்ணுங்க சார், ஆன் பண்ணுங்க, ஆன் ஆகல, ஆன் பண்ணுங்க, ஆன் பண்ணுங்க. தெரியல, இல்ல இல்ல, பிரச்சனை இல்லை, இப்போ கனெக்ட் ஆகும், கனெக்ட் ஆகும். கனெக்ட் ஆகிடுது சார், ஆட்டோமேட்டிக்காக ஆகிட்டு, ஆட்டோமேட்டிக்கலி கனெக்ட் ஆகும். பரவாயில்ல சார், லாஸ்ட் நான் G6 காமிச்சுன்னா வேலை முடியும். ஸோ G6 மட்டும் எக்ஸ்பிளைன் பண்ணுங்க. இல்லை நான் ஸ்டெப் சொல்லிடுறேன், ஸ்டெப் சொல்லிடுறேன். இல்லை நான் ஒரு நிமிஷம் இதில் நான் சொல்லிடுறேன். ஓகே, go to quick group statistics. Go to quick. Have you seen the group statistics? Go to quick. Have you seen the group statistics? Group statistics. If you look at the group statistics, the last option is Granger causality. Okay, go for, just click it. Granger causality test, click it. You got the window. Oh, estimated. Okay. So is it asking the lag length to include, right? Yeah, series. Okay, it's as the list of series. First one, D of. Open the bracket. LS. Same thing what you specify, the same thing. D of within the bracket LS. Space. D of within the bracket LF. Now that asks, no, if you click OK, it asks the lag length to include. So how many lag length? We'll go for 1, 2, 7. Which one you want to go? We'll go with 7. Okay, give 7. Click OK. Click OK. What is the result? Click OK. You got the result? No. What is the result you got? No, look at the hypothesis. You got the F test or T test? F test. I told you, no. See, the Granger causality test is based on F. Why? Because it is used a F test. Yeah, what is F test? F test used to test the joint significance of the coefficients in the model. Okay. What is the first one? What is the first value? Sir, done, sir? Can I have a look? Okay, sir. The same result we got. So whatever the result, I told no, the Granger causality is the short form of VAR model. The same thing only. Okay. Go for lag length. No, lag length 1. We'll see. How to go? Go to view. Granger causality is the last option. Same. Keep the result and go to view. Last option, the Granger causality. Okay. Click, give the lag length 1. Give the lag length 1. So what is the result? Again, insignificant. How hard so many times you try insignificant. You know what is the reason? I'll tell you later. What is the reason for it? I'll tell you the reason why it is insignificant. Okay. Some of you might know it. Okay. Can you give the lag length 2? Go to view. Granger causality. Lag length 2. Again, insignificant. அது ஒண்ணுமே இல்லை, 0.00. Okay, so what is the conclusion? I tried VAR model with the different lag, and also sometimes no joint effect collectively will get some significance. You do not know. When you look at the joint significance, sometimes there is an improvement in the F value. But the data set which we got says that no, there is no, conveys that there is no relationship between these two. That means both are independent. Both are independent. Okay, both are independent. So what to do? So there is some issues with the model, either some issues with the model or the data that you have collected. Data that you have collected. Okay. So you learn no that how to estimate VAR, and how to perform the Granger causality test. I will give one sample. I'll show one sample result. You just tell me the inference. Okay, here I'm not going with the procedure. I'm going to display a sample because you know the procedure, right? You already estimated. I'll show you the sample result. Just tell me what is the result actually. What is the outcome? I'll show you the sample of sample outcome. Show me explain me the result, convey the result to me. Okay, inference. Okay. So now let me go with oh, I can't do it also. What are the answer there? Marubiyam. Sir, நான் என் phone connect பண்ணி பார்க்கவா? Personal Wi-Fi usually. Connected. Okay, audience. I am going to estimate it. Have you seen the screen now? Forget about it, the estimation part. I'm going to do, I'll show you the sample, okay? Okay, look at this result. Anyway, I have used the log data. Anyway, this is wrong. But here I'm just showing just how to write the interpretation. Now look at the equation. LS is a function of lagged value of LS, then lagged value of LF. Is it significant? No. Now look at the other equation. Yes. This is significant. 2.45. So what is the inference? What you will make out? So what is the conclusion? No. Correct. What he said. That's what I want to show the sample now. The change in S leads to change in F. So S causes F. Correct? No, this is the way to read the data. Write the conclusion. That's what I have given. Otherwise, no, I don't want to skip with the independent relationship. Tomorrow you got one way, how to read, you don't know then how to read the data. So F leads to, the S leads to F. Correct? Yeah, it's a unidirectional or one way. Okay, I'll go to the GC now. Granger causality with one lag. Go to view. Go to quick group statistics GC. A list of, let's say, LS and LF. Click OK. And lag length, let it be 1. Yeah. Super. Okay. So, tell me now. Look at this result. The first one. What is null? F does not Granger cause LS. Is it F statistic significant? Look at the probability value. No. So I don't want, I will go with the null. Since the p-value is very less, I'll go with a null that F does not cause. Yes. Look at the other way around. The other side, the next one. Yes, 5.93. So you are rejecting the, look at the probability value is less than 0.05. You are rejecting the null and accepting that yes causes. Same result what we got, the same thing. Short form, that is the full specification, the form of full specification. Full specification. Bar model is about the full specification. Got it? No, because I want to show the result to write the interpretation. Got it? No. But the thing is, one question mark, I want to leave you with a question mark. Why this result? We got an independence. We got I'm not happy with the result which we got. Both are independent. Okay, both are independent. But there is a mistake here what we have done it. Nothing wrong in getting independent because the data speak, no, because that's the data. So we are getting the independent relationship. With the proper procedure I went. So why we are getting independent? To understand, no, need to be, see, if it is getting one way also, there is a proper procedure. So what I have done it, I have done a VAR model in the first difference form, correct? Correct, no? But I got an independent relationship with it. But as per the proper econometric procedure that we discussed in the morning, what is the first step? What is the first step? First step is stationarity. So, when both the variables are stationarity at the first difference, both the variables are stationary at the first difference, what do you have to do? What do you have to do? You have to go for? You look at and tell me. Just see your notebook and tell me what you have written. Co-integration. After co-integration, Weck model. So no point in go for the VAR model. The representation should be Weck. The specification should be Weck, not VAR. Since this variable, but anyway, nothing wrong in trying VAR. Nothing wrong in trying VAR. For robustness, we can still try GC. Understand now GC, and still you can try VAR for the robustness. But what we will do is, tomorrow, I will run the co-integration test for this data. Then I will run the error correction model for this data and see if there is any difference in the result, because both are same, no, causality purpose only. We will see. Okay, is there any change in the result? So tomorrow what I can do is, I'll start with the co-integration followed by error correction model. Okay, then we'll see any changes in the data. Then we'll proceed. Understand, no? If time proceeds, we'll go with the ARDL. Otherwise, no, we'll go with the GARCH, eGARCH. So tomorrow I'll circulate an article. Not tomorrow, today only I will forward the 2-3 articles. Sir, I'll forward the article to your mail, sir. Forward to them. Two good article I'll forward. So that no, it'll be easy for you. And data set also I'll forward, sir. So that no morning you will get no. At the time of GARCH and no, eGARCH you can open and you can learn. Okay, with this, I'm going to teach you with respect to a particular objective. Then it will be easy for you to learn ARCH and GARCH. Okay. So any doubt? I'll take some questions. If you have any doubt, I will take. So because this is a 3 days, I'm going, I'm pitching a little slow. Stable, not slow, stable. Otherwise, no, you should not lose the grip. That is the reason. Otherwise, no, I'll go fast. No issues. Estimation, explanation. I'm just giving you a proper, the feeding, a proper, mix of the ground, the theoretical ground and the practical thing. If I go fast with the practical, you will miss the concept. If you go with more concept, no, you'll miss the hands-on. So that's what I'm very carefully go ahead with. So any questions? Yes, sir. Yes, sir. Equations, correct. Yes, sir, definitely. Because I'll tell you, each and every research paper, if you look at, there is in the research process, there is a methodology. Sometimes you say data and methodology. So where the data collected, which source you collected from, no source, what type of data or time period. Similarly, method also very important. I can't simply say the study employed VAR, or study employed VCM, or study employed Granger causality. You should give at least a simple form of specification. Simple form, you understand, no? Like this. This is a simple form of the VAR model. Don't go for the same VAR model. If you want to go, you can give 2 pages of equations. All notations, no? The derivation part, not required. Nowadays, these models have become a common model for all the paper. So you have to give simple specification in a very, simplest way. Some editor, the journal editors, or some reviewer, they want little more detailed explanation on the methodology. Some people know it. This is a very common model. So no issues. So no need to go for it. So again, it depends upon the journal's policy. Journal policy means the editor's the decision when you're writing paper. Some editor, least bother. Okay, simplest form of the VAR model or Granger is fine. So you go ahead with that. So a kind of, but specification is, the equations are important, sir. Whatever the model you are at. Not with the basics. Unit root is not required. Because unit root is a basic expectation, a basic condition, the fundamental criteria, right? No, for the time series analysis. We don't want any unit for unit. But which model is the main model? The VAR model or VCM is the main model, which you have to give the specifications.
One doubt.
Yes, sir.
So yesterday you mentioned about auto correlation. Today, VAR is basically auto regression method. It's slightly confused between auto correlation and auto regression, these two terms.
See, dummy variable, why we are using dummy variable? Because sometimes the variables are qualitative nature, which we can't quantify it. See, for example, latest, I have come across how to capture the COVID impact, COVID effect, or I'll tell you, the reaction, the effect of behavior, stock market behavior, let's say simple. Stock market behavior, the stock price reaction before COVID and after COVID. Very simple. Can we capture the stock market reaction? See, I want to capture the COVID impact. COVID impact. Before and after. Before and after. So what is before? Before means what? When the COVID year started? COVID-19, 2020, January. 2020, January. Okay. Before, after. Before, after. So what is the stock market behavior? I want to see. Okay. See, for example, I'll specify and I'll explain. See here. Let's say the returns. or share price or returns I have mentioned. The importance of the dummy variable. So in econometrics, there are two dummy. In econometrics, we have only two dummy. What are they? 0 and 1. We have dummy 0 and 1. So now I am just looking at the pattern of the behavior of stock market, right? You take returns is equal to alpha 1 plus beta 1. Okay? RT minus 1. No issues. Correct? No. The present return is influenced by the past return. Plus, listen carefully, beta 2, I am going to introduce dummy. I am going to introduce dummy. Plus UT. So what is this dummy for? Dummy for also 24. This is January. This is to November, latest. Understand, no? So what is the data? January monthly data. Let's say monthly data. January 2010 to November 2024. Very simple. Dummy, I'm going to incorporate dummy. Why? To find out the share market, stock price reaction before COVID and after the announcement of COVID. Purpose has to be clear. Morning also, I told you, the objective need to be very clear. Okay. So how to bring the COVID here? Number of death. Correct? No, I can't bring based on number of death due to COVID. So what I'm saying, I'm going to create a dummy. So I create a dummy, D. What is D? D is COVID effect or the COVID pandemic outbreak. The dummy related to COVID-19. Sir, how to incorporate here? How to incorporate, I'll tell you. Okay. So what you supposed to do? January, what is the starting date? Starting month? January 2010 to till November 2024. November, gentlemen, listen, 924. Now I have to assign 0. Where? From January 2010 till 0. Till which month I have to assign 0? COVID, very good. January 2020. So till December 29, correct? No, December 2019, I am assigning 0. And after that, I am assigning 1. Beautiful. 1. Till now. This is before announcement. This is after announcement. So what is my objective? I want to find out the reaction of share market, Nifty 50. Is there any changes in the behavior, the persistency effect? Changes in the behavior, changes in the returns before the announcement and after the announcement. So I incorporated dummy to capture it. And not only that, there is another use also. Some variables cannot be measured. For example, macroeconomic news announcement. The RBI comes out with the changes in the repo rate. Changes in the repo rate. So repo rate I cannot consider. Repo rate I am not consider because it is same throughout. Repo rate changes very rarely, no sir. Yearly once or twice it changes, not frequently. So no change in the variable. But the RBI come with announcement, there is a changes in the repo rate. So how to capture? Incorporate the dummy variable. Before the announcement, 000. After the announcement, 111. So I am capturing the effect of the macroeconomic news announcement on repo rate on what? On share price reaction. So audience, this is the purpose of dummy, where you can't measure certain variable which are qualitative in nature. In that scenario, you can assign dummy which carries 0 and 1. So again and again, I'm telling, please careful with the dummy variable. Otherwise, you will fall on the dummy variable trap. I have written a beautiful paper on day of the week effect. If I think, gentlemen, the professor will be, that the gentleman asked question. He is from maybe economics and finance. So I have written on paper. Well, I share my article. It is all about the day of the week, you know anomaly, right? Calendar anomalies. So day of the week effect, beautiful paper on the share price. Okay, so you can refer, I will share to our HOD sir. He will forward to you. 5 dummies I have created. How many dummy? 5 dummies. You can't create 5 dummy because 5 days, 5 dummy we can't create. So M-1 principle. There is also, if it is 5, you should go for 4 dummy. Should not create 5 dummy. If you want still create, you have to remove the intercept. Otherwise, you will be in a dummy variable trap. So, gentlemen, again, this going deep about the dummy variable model. So, what I'm saying, I will just give my article, beautiful article, very simply written, and is published in Scopus as well. So, five dummy I incorporated with removing the intercept. Monday effect, Tuesday effect, Wednesday effect on the share price. You heard, no, Monday the market will be little slow. The Tuesday and little rise you can see, and at the end of the week, and you can say market is on rise. So you can use dummy. How can measure this effect? Anomaly effect, how to measure? Dummy. Monetary policy announcements, how to measure? Dummy. We can't measure, no. We can't quantify. Dummy. All anomalies, no. Dummies. Week of the day of the week, month, all. Okay. So hope I answered, gentlemen. Any other questions? No, actually, please, nowadays the model which is developed, the number of observations not required. So war model, usually war model, you know, it is since the war is based on T test no supported by 30. So what is the sample size? 30. So minimum 30 is required because the war is based on T. Nowadays, no need to worry about the sample size because the ARDL model. So tomorrow I will run and show you. So what is the advantage of ARDL model? The critical values, constructed for ARDL. So by Pesarin in 2003, so it has, like very powerful, and it also, suitable for where the sample size, even if it's 10 also you can do, 12 also you can do, and 15 also you can do, no issues. Madam, when your sample size is less, the econometric model, no problem. Okay, don't stick to war minimum 30. In ARDL model. Is it related to autocorrelation concept? Yes, sir, same thing. But here, war model, I will give just very briefly because tomorrow I will explain detail when I am teaching the error correction model and ARDL model. Actually, very simple. Here, what we have seen what is autoregression. Yes, same thing only. What is asked, the answer is there. Yesterday, I've explained about AR, right? AR, what is AR? YT is a function of YT minus 1. So AR1. In war model, we use the same. YT is a function of YT minus 1, YT minus 2, plus 2 more term we introduced. 2 more term. What is the term? This is not autoregressive. The lagged variable of independent variable we have used, which we call it as an endogenous variable. Please try to understand. But here, why we are going for its lag, you know the concept, no? Like when you go for war, especially war model, why we are going for lag? Because to control the problem of autocorrelation. War model, why we are going for it? Because it is the main why we are going for model, because that model, advantage of the war model is to take care of the issue of autocorrelation problem, because YT is a function of YT minus 1 and also XT minus 1. The problem of autocorrelation will be subsided. Yes, that reason only we are going for war. And in fact, objective should be always the causality only. Okay, sir. So this war model, it is based on AR setup. That means AR terms are there. AR terms of the dependent variable. YT is a function of YT minus 1. You can look at here what I specified today. YT is a function of YT minus 1 plus not only YT minus 1, it is lagged XT minus 1. Okay, but subject to we are capturing the effect from the AR terms. That's it. That is the reason we go for the lag, all this lag length, find this. Okay. So okay. So hope I
Thank you.
answered. So any questions now tomorrow also I'll take it, make a note. The doubts I'll clarify tomorrow also. Okay. So tomorrow we'll see. I'll start with the co-integration. We'll go for the WEC model. Once I finish WEC model, maybe I'll go for one ARDL model. It's easy. Then I'll go for the ARCH and GARCH. Today I'll forward the materials. Just go through it. It'll be easy to understand these models. So thank you. Thank you. See you tomorrow, audience. Thank you.
Thank you, sir.